You know how massive companies like Netflix or Amazon can somehow serve millions of people all at once and just not crash? Well, the secret isn't just one magic trick. It's a whole philosophy, and it's backed by a set of absolutely brilliant tools. So today, we're going to open up that essential toolkit for any modern developer, microservices design patterns. Okay, let's get into it.
But first, let's start with a situation that's, well, it's probably a little too familiar for anyone who's ever built software. You've seen this happen, right? A single tiny bug in one little corner of the system starts a domino effect, and before you know it, the whole application comes crashing down. It is an absolute nightmare scenario, and it really points to a big problem with the old way of building things.
And this lays out the whole difference right here. On the left, you've got the monolith. It's one giant, tangled-up process. If one part breaks, the whole thing can just collapse. But on the right, you see the microservices way. It's a collection of smaller, independent services. Now, if one of them fails, the others can just keep on chugging along, containing the damage. And that brings us right to the heart of the matter, the monolith problem. I want you to picture this massive, super complex machine with thousands of gears all turning together. Now, what happens if one tiny gear, deep inside, just breaks? The entire machine just grinds to a halt. And that is the exact risk we're running with a monolith.
The reason why is that everything is just so dangerously interconnected. A bug in, say, the user profile feature could have these totally unforeseen ripple effects that end up crashing the payment system. It's this tangled web of dependencies where a failure anywhere can, and often does, become a failure everywhere. This is the monolith's greatest weakness, for sure.
So, what if we could build our systems to be more, resilient from the ground up? This is exactly where microservices come in, and it's a complete game changer. It's not just about patching up the monolith, it's about thinking about software architecture in a totally new way.
And the benefits here are huge. I mean, what if you could update one part of your app without taking the whole thing offline? Or what if you could scale only the specific services that are getting hammered with traffic? You can even use the best programming language for each specific job. The most crucial point, though, is that we're building systems that are designed to stop that catastrophic failure from ever happening in the first place.
Okay, so how do we actually build with microservices without just making a huge mess? Well, we use design patterns. These are the proven blueprints, right? The recipes for success. They are the tried and true building blocks that stop you from reinventing the wheel and help you create a solid, reliable system from day one.
So, where do we start? Well, the first set of tools in our toolkit tackles one of the toughest challenges in any distributed system: managing the data. How do you keep your information consistent across a whole bunch of services, while making sure each one stays truly independent? The foundational pattern here is called database per service. The rule is simple, but it is totally transformative. Every single microservice is the one and only owner of its own database. No other service can reach in and touch that data directly. Now that might sound basic, but that's the core idea that gives us true independence between services. And this just lays out the trade-off perfectly. When you give each service its own database, you get enormous flexibility. Your order service can use a classic SQL database, while the product catalog uses some super fast NoSQL database. But if you share a database, well, you're tying them back together again, and you lose the very scalability and independence you were trying to get.
But wait, this brings up a huge question, right? If all these services have their own private databases, how do we handle a single operation that has to touch multiple services? Just think about placing an order online. It's a bunch of steps. You have to update the inventory, process the payment, create a shipping request. The Saga pattern is what makes sure all these little steps succeed or fail together as one single, consistent thing.
Now, the Saga pattern comes in two main flavors. Choreography is kind of like a well-rehearsed dance. The inventory service does its thing and just announces, "Hey, I'm done," and the payment service knows that's its cue to jump in. Orchestration, on the other hand, is more like a symphony conductor. There's a central manager telling each service exactly what to do and when. Choreography is awesome for simpler workflows, but orchestration gives you that tight control for the really complex stuff.
Okay, let's move on to the next set of tools in the box. And this is where it gets really interesting. We're talking about patterns for service communication. It's not just about how services talk to each other, but maybe more importantly, what happens when one of them just suddenly stops talking. First up is the API gateway. Just think of it like the single official front door to your entire system. Instead of your mobile app needing to know the addresses of dozens of different little services, it just talks to one place, the gateway. And the gateway acts like a smart traffic cop, directing all the requests to the right place.
And this is absolutely huge. It completely shields your users from the crazy complexity going on behind the scenes. And what if you could have a single place to handle all your security and authentication? Yep, the gateway does that. And this is critical. If one of the back-end services goes down, the gateway can still serve up partial data from the others, which prevents a total failure for the user. Okay, now this pattern is a total lifesaver, the circuit breaker. It works exactly like the circuit breaker in your house. If an appliance shorts out, a breaker flips to stop it from burning the house down. It's the same idea here. If a service starts failing over and over, the circuit trips. This immediately stops hammering the broken service with more requests, giving it a chance to recover and protecting the whole system from getting dragged down with it. It's got 3 simple states. First, it's closed. Everything's working, requests are flowing. But then, failures start to add up. The circuit trips to open. Bam! It instantly protects the system by failing fast. Then, after a little timeout, it carefully moves to half open, and it sends just one little test request through. If that works, the circuit closes again. If it fails, it stays open. It's just an incredibly smart way to build self-healing systems.
So, all of this sounds great in theory, but how do you actually get there? I mean, how do you take a giant existing monolith and move to microservices without, shutting everything down for 6 months? Let's look at the patterns for that exact journey.
The most famous strategy for this is called the strangler pattern. The name is pretty dramatic, I know, but the process is actually really methodical and safe. You carefully build new microservices around the edges of the old monolith, one piece at a time. The key here is doing it incrementally, which minimizes risk and lets you keep delivering value the whole time. Eventually, the new system completely surrounds the old one, and the monolith can finally be put out to pasture.
But how do you even decide what to break out into a new service? The decomposition pattern gives you a great framework. You can split things up by business capability. That's the most common way, right? A service for inventory, another for payments. Or you could split by subdomain, carving out a really complex piece of logic into its own world. You can even break it down by a single transaction, grouping all the services you need to process, say, an insurance claim.
As the team over at Capital One Tech puts it, the goal here is pretty straightforward. Use these patterns to build an app that's both robust and functional. These aren't just ideas from a textbook. They are battle-tested tools for getting a really tough job done right.
And that's really the main thing to take away from all this. These design patterns are not just some abstract rules you memorize for a job interview. They make up a real, practical toolkit for building software that's more resilient to failure, way easier to manage and update, and ready to scale up whenever your business needs it to. So I'm going to leave you with this question. Looking at what you're building right now, which one of these patterns, from the Saga to the circuit breaker to the strangler, could be the one to really transform your next project? Thanks for joining me on this one.